Uh, all sides of quadrilateral are equal. We call the quadrilateral inverse. Where rectangle quadrilaterals we call rectangle quadrilaterals. Quadrilateral having all four angles equal to 90. Where all angles 90, all sides equal. Area of triangle half base into 90. Area of square into basic things which we are going to use without really proving them. Definitions need not be proved, but area of triangle are basic to identify. We have to prove it some way or other. Right now we will borrow. We have to prove. So these two things are without at the moment. Eventually we prove that those also in class. So if these things are there with us, we have a good application. Suppose we have a triangle, single triangle with sides A, B, and C. Now, normal notation, side opposite to capital A, vertex capital A is small a. Side opposite to vertex capital B is small b. Side opposite to capital C is small c. So this is triangle ABC, right angle at C. This is a standard notation. Suppose somebody says that length of the side of the triangle is small l, that means the vertex opposite to this small l is capital L. Okay, so we have a right angle triangle with us, and then we have a configuration where we take a square of the length a plus b. ABCD is a square. PQRS are It's taken on the sides of square such that AP is small b, PB is small a, BQ is small b, QC is small a, CR is a small b, RD is small a, DS is small b, and SA is small. We can construct a square looking like this. Okay. Then we join PQ, PS, we join SR, we join PQ, and we join QR. Okay. This is the configuration. Now, we started with square whose all sides are equal and all angles are equal. Therefore, these angles are 90 degree because we have four interior angles for a quadrilateral, and we have already proved that the sum total is 360. Therefore, each angle is 90. Okay, so we will start using congruency. Now we have triangle ABC with us, and we have ensured that in this construction we have created four more triangles which are going to be congruent with ABC. So let us start writing. Statement 1. Triangle ABC is congruent with ABC, small, big 90. Small, big 90. PSA is congruent with triangle QPB is congruent with triangle RQC is congruent with SRD.
Sir, will it be RCP?
Wait. ABC is congruent with PSA, QPB, RQC, SRD. I think this is correct.
हो सर बरोबर आहे माझं चुकलं मी ABC वेगळा दिला.
Okay. Now it is important to write by which test it is congruent, and the test is SAS because we have constructed it. Dot 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 SAS. Correct. So we have used three things to make these two triangles, or maybe four triangles and five triangles congruent. Therefore, we can deduce so many things. Admit. For convenience, let us call this angle X, this angle Y, and this is 90. So therefore, let us write side. So if this statement is true, it will imply SP congruent. Oh, let me write down SP AB congruent with PS with QP congruent with RQ congruent with SR. CSCT. Correct. Then we have angle APS. APS, which is BAC. Yeah. Angle BAC congruent with BAC. Angle SPA congruent with angle PQB, congruent with angle चुकलं, PQB. Congruent with angle QRC, congruent with angle RSD by CACT. And there is one more angle, BAC, ABC, that is correct. So this also implies, first statement implies these three things: angle ABC, congruent with angle PSA, congruent with angle QPB, congruent with angle RQC, congruent with angle SRD, again by CACT. Clear? कुठे काय doubt असलं तर so let us decorate this figure now. These are equal. This angle is X, this angle is X, this angle is X, and this angle is X. This angle is Y, 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 and Y. We can write actually this side is equal to small c. This angle is equal to BAC X. This angle equal to Y. Good. So if we keep giving numbers, so this is statement 1, statement 2, statement 3. Sorry, statement 1 implies statement 2, statement 3, statement 4. 1 implies 2, 3, 4. So 2 implies PQRS is a rhombus. बरोबर आहे काय करतो बोला हो एबीसी इकडे काढलाय हा अच्छा ते क्लॅश होतात ना बरं ठीक आहे ओके इकडे हा एबीसीडी क्वाड्रिलॅटरल आहे आणि हा एबीसी एक सेपरेट ट्रायंगल आहे सर ए आणि बी क्लॅश होत आहेत पण आता 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 चेंज करणं अवघड आहे जरा बऱ्याच ठिकाणी लिहिलंय इकडे पण एबीसी आहे असा हो येस मिस्टेक So let us draw a line here. This ABC is different than this ABC. So PQRS is a rhombus. Note X plus Y plus 90 is equal to 180. Implies X plus Y is equal to 90. And therefore, measure angle PQR is equal to measure angle QRS is equal to measure angle RSP is equal to measure angle RSP SPQ equal to 90. Linear triple out of which two angles are known to us. Addition of them is 90. Therefore, remaining third angle is also 90. This implies PQRS is square. Correct. So it is a simple application of SAS test congruence. We could arrive at a conclusion that ABCD was square. Now PQRS is also square. So measuring same quantity in two different ways. If we measure the same quantity in two different ways, we will generate an identity. The quantity will not be there, cancelled out, and we will generate an identity. So this is very important problem solving strategy. We measure the same quantity in two different ways. In addition is commutative or multiplication is commutative. We use this principle. 4 rows and 3 columns, total 12 dots, measured in two different ways. Therefore, 4 into 3 is equal to 3 into 4. Okay. So now we are going to measure area of ABCD, square ABCD. Area of square ABCD. Now, box brackets, whatever you put inside is area of quadrilateral ABCD. This is the notation ABCD. So one way to measure the area of quadrilateral ABCD is it's a square, so we can use side is a plus b and therefore a plus b bracket square. But the other method of measuring the area is area of APS plus area of BQP plus area of CRQ plus area of DSR plus area of PQRS. We measure the same area in two different ways. We have proved all these four are triangles which are congruent to ABC. So till this point we do it on board, and then after this we allow students to do the simplification and calculations, and then after the couple of steps you will get an identity. Dot dot dot. Get me the identity when we simplify. Measuring the same area in two different ways. Nobody is supposed to talk. You should show me the identity after simplification that you get. Yes. Anup sir, correct. Preeti madam, simplify. Jyotsna madam, not visible. खूपच. सुमेधा मॅडम सिम्प्लिफाय. नॉट क्लिअर. ज्योत्स्ना मॅडम, वैशाली मॅडम, अजून जरा क्लोजअप द्या, अजून जवळ. आय थिंक इट इज करेक्ट. तुमच्यापैकी झालं तर सांगा.
इज दिस विसिबल सर? नो ना?
नो. पूर्ण कॅमेऱ्यासमोर वही दिसू द्या, तुम्ही नाही दिसलात तरी चालेल. काय डेट दिसते 10.
नॉट एबल ना?
नाही,
नॉट एबल टू होल्ड इट.
ती वही दाखवते ना तुम्हाला. मी व्हाईट स्लेट दाखवायला सांगितली होती. व्हाईट स्लेटवर जरा मोठ्या फॉन्टने लिहिता येतं. वहीमध्ये तेवढा मोठा फॉन्ट असत नाही आपला. शुभांगी मॅडम नॉट करेक्ट. सिम्प्लिफाय. अर्पिता मॅडम सिम्प्लिफाय. हा, तुमच्यापैकी झालंय सगळ्यांचं? बघू का मी? हा, अरे अजून याला एक्सपांड. हा, हे अजून ह्याला पण एक्सपांड करा, सिम्प्लिफाय करा अजून. ह्याला एक्सपांड करा ना. नाही खरं. एरिया हाफ बेस इंटू हाईट. हा, ह्याचा काढा म्हणजे लवकर होणार. हा, नाही, ए प्लस बी ब्रॅकेट स्क्वेअर लेफ्ट हँड साईडला आहे एबीसीडीचा एरिया, आणि बाकी सगळे एरिया राईट हँड साईडला आहेत. आहे की नाही? हा, बघूया. हा, बरोबर. शाबास, व्हेरी गुड. करताय मॅडम. ह्याचा एरिया लिहिला नाही. ए प्लस बी ब्रॅकेट स्क्वेअर. नाही, ह्याचा पण करा अजून लेफ्ट हँड साईडचा. नाही, बोलायचं नाही. नाही, नाही, आता हे बघा, इथपर्यंत समजलं. आता एबीसीडीचा एरिया काढायचा डाव्या बाजूला. तर तो स्क्वेअर आहे, डाव्या बाजूचा स्क्वेअर आहे. त्यामुळे त्याची साईड आहे ए प्लस बी, त्यामुळे त्याचा एरिया काढता येईल आपल्याला. आणि राईट साईडला 5 तुकडे गेलेत त्याचा एरिया काढता येईल. करा करा करा. मी म्हणून मुद्दामून सुरुवातीला आय एम हवे की तेवढे तुम्हाला ते आठवणार नाहीयेत, म्हणून माय फर्स्ट स्टेटमेंट वॉज दिस. This is required. I mean, I have used rhombus in the proof. I have used square in the proof. I have to use area of triangle half base height to height in the proof, and I have to use area of square in the proof. That is given to you now. This is available. So, हा, व्हाईट स्लेट आहे का? तर दिसेल. हा, सोनाली मॅडम, सी स्क्वेअर दिसतोय. त्याच्या आधी काय आहे? त्याच्या आधी 2ab आहे. बरं, मग थोडं अजून पाहिजे का? अमृता मॅडम, 2ab दिसताय, अजून काम करायचंय. कोटेश्वर सर करेक्ट, अँड दॅट इज ऑन व्हाईट बोर्ड. व्हेरी गुड. बाकी कोणाचंही दिसत नाही, सगळ्यांच्या छोटे छोटे वय आहेत. ओके, लेट अस डू इट. Now, measuring the area in 2 different ways. Area of ABCD is A plus B. Side of this square is A plus B. Bracket square is equal to APS is a triangle congruent to this ABC. So, finding out area of right angle triangle is the easiest thing. It is multiplication of 2 non-hypotenuse side divided by 2. Because one, you can consider one as a base, another will be height. So the area of this triangle is AB by 2 plus AB by 2 plus AB by 2 plus AB by 2. And PQRS we have proved to be square, and its side is congruent to AB. That means This side is C. All the four sides are CCCC and it is a square. Therefore, this is C square. This is what we get as an identity, and area of a square is not there in the picture now. It has gone because we have equated area, calculated area in two different ways. Now, if we simplify this, then it is a square plus twice AB plus B square. In LHS, half is 2 times AB plus C square. And we will observe that these 2AB in LHS and 2AB in RHS will get cancelled, and we will get a square plus B square is equal to C square. This is the identity that we will get using this simple technique, area and congruency, which is Pythagoras theorem.
सर एक बोलू का?
In the triangle, we got this identity. हा बोला.
सर हे करताना मी सी न घेता चुकून तिथे म्हणजे √(a² + b² असं घेतलं होतं. तर याच्यावरून ती आयडेंटिटी पण प्रूव्ह होते की a + b होल स्क्वेअर इक्वल्स टू a² + b² + 2ab.
नाही, आता आपण ज्या क्रमाने चाललेलो आहोत त्या क्रमाने तुम्हाला ही साईड √a² + b² घ्यायची अजून परवानगी नाहीये, जोपर्यंत पायथागोरस प्रूव्ह होत नाही.
हा हा बरोबर.
हा, त्यामुळे दॅट इज वाय आय एम प्रूव्हिंग इट इन 5th लेक्चर, पायथागोरस थेरम, विच नाव वी कॅन यूज. सिक्वेन्सला महत्व आहे. ओके, एनी डाऊट? Not proved, but for proving that we don't require Pythagoras. We will take care of that. If we use Pythagoras for proving area of triangle and area of square, then we are gone. I mean, we just cannot do it. Loop मध्ये जाणार. Yes, this is algebra side of mathematics, which we will have to prove. Yes, correct. Our aim was to prove Pythagoras. And another aim is to show students that using simple basic tools like congruency of triangles, area of triangle is base into 8, and area of square is side square, we can do the proof of Pythagoras theorem at 8th standard level, which is normally not taught till 10th standard. They have a similarity proof in 10th standard, not this. But this proof is good. And when I started teaching in 2008, there was a wow movement. The moment students used to get this. But now it is not, because there was one advertisement of Byju's where they have used this proof in their advertisement. So recently, the last few years when I taught, the moment I draw this diagram, students start talking about Pythagoras. So that is the revolution. I used to tell them की तुम्हाला हे सिम्प्लिफाय करा, मग तुम्हाला एका देवाचं नाव दिसेल, आठवेल. ते आठवलं की मला सांगा. मग ते एकदम असे ओरडायचे, सर पायथागोरस म्हणतात वर्गात. Okay. Any doubt, difficulty? This is the first proof that we teach in 8th standard, and like this, as we do advanced theorems in mathematics in the class, we talk about 16, 17 different proofs of Pythagoras theorem. Pythagoras theorem is a very celebrated theorem. Every new mathematician which comes wants to prove Pythagoras theorem differently. So there are more than 300 different proofs of Pythagoras theorem. And all the great, including Euclid, who is supposed to be doing this geometry, conciseness of this geometry 2000 years before, even he has got his own proof of Pythagoras theorem. त्यामुळे Pythagoras theorem, proving Pythagoras theorem, we ask couple of proofs in our exams also. 8th standard exam, we ask couple of proofs for students to prove Pythagoras theorem, given some conditions. So this is not done anywhere in India, And at the level where we teach 8th standard, it might not be done anywhere in the world on a mass scale. I mean, one-on-one, people must be discussing this, but not in the classroom training. Okay, so having got Pythagoras theorem with us, using congruency, let us try to use Pythagoras theorem to develop something more. Now, you might not recognize now my whole direction of teaching now is how can I make a very good question paper after 8 lectures, so that therefore I am borrowing few things. Otherwise, I should have gone very systematically and taught you why area of triangle is half base into height, why area of square is side square. Everything need to be done very systematically. But now I am jumping little bit because I can do that little later, but if I keep doing those rigorous proofs, then I won't be able to ask you anything in the exam. So let me do some compromise and we will complete all the pending things later on. Okay. Okay, okay. Now I want to let us discuss area. No problem. We have sufficient time. Suppose I want to find out to start with area of this rectangle. Let us take some sides. 5, 3. We want to find out area of rectangle. And it is said that 5 into 3, 15 is square, unit square. 15 unit square is the area of this rectangle. That is what is being taught to us. And now we start asking questions. Why is area 15 units square? So maybe the answer is easy. We are measuring area, and at the moment we start measurement, it is a comparison process. Measuring anything is a comparison process, and therefore we need to have a unit of measure. And the simplest, I mean, we can have whatever unit of measure that we want. I mean, we can fix that this triangle is 1 unit. Equilateral triangle of one length 1 is 1 square, 1 unit area. We can say 1 unit area. But then this is going to be difficult. I mean, using triangle to measure the area of at least simple figures is going to be extremely difficult. Therefore, after so many iterations, they must have arrived at, let us have a unit square. 1, 1, 1, 1, and it is a square. So that might be the simplest figure, which is a unit of measure. So 1 square unit, which is unit of area. Area is measured in square units. So you draw one square, decide that it is your unit of measure, and then measure the required area comparing with this area. So we have created our unit of measure. Now, if it is 1 side 1, and we have got 5 side here, so we can divide this in 5 parts, and we will observe that exactly total 15 units, 15 squares are fitted in this rectangle, column wise 5 and row wise 3. So total it is area of, say, ABCD. Five into 3, and that is all. I mean, first is very simple. It is 15. If the length of this rectangle is a natural number, and if the width of the rectangle is also natural number, then I think this will work. Very simple. Row wise, you will have whatever length you have, that many squares. Okay, this is area. So I am just counting column wise. There are 5 columns and 3 rows. So total number of squares is 15 and area of each square is 1 square unit. Therefore, area of ABCD is 50. Okay. Square unit. Okay. Good. Suppose my side is next example. My side is little more than 5 and width is also little more than 5. 5.3 and 3.6. I have a rectangle with sides 5.3 and 3.6. Then what will be its area? Those squares will not fit in this. I mean, some of them will fit, but then something will remain. Correct? So, but the process is same. You start putting those squares back in the given rectangle. So now maybe up to 5 we are okay. And up to 3 we are okay. Here this is fine. 1, 2, 3, 4, 5, 2, 3. This is 50. But then we have some additional area. We will not, I mean, we will not be able to put a square here. We will not be able to put a square here. Okay, so what do we do? I mean, using this unit of measure, we have 1 square unit, which was our unit of measure. We divide it in 10 parts, horizontally, vertically. So we have got 100 units, tiny squares over there, each having length 0.1 unit, correct? Every tiny square will have length and width, I mean side 0.1, 0.1 square unit. Okay, so we will take 0.3, I mean 3 tiny squares and put here. Up to this point we are done, okay? And then we will put 6 tiny squares here, correct? And then we can occupy. So totally there are 53 tiny squares from here to here, and there are 36 tiny squares from here to here. Correct? थोडं फास्ट करतोय पण ते सोपं आहे म्हणून फास्ट करतोय. This is easy. If we measure total number of tiny squares column wise, they will be 53, row wise, they will be 36. So if I want to find out area of ABCD, I use the same procedure. First, I find out the total tiny squares. Earlier, they are 53 into 36. These are tiny squares. And area of each tiny square is 1 upon 10 into 1 upon 10, because we have divided the unit square in 10 parts. This is going to be total area. But then we can write this as 53 upon 10 into 36 upon 10, which is 5.3 into 3.6, which is whatever area that you want. So what we are trying to do is length into width. So here, this is length into width. Here we have finally arrived at length into width. So if we have a decimal, if our sides are not integers, if they are 1 digit sides, then we can use this technique and arrive at rectangle area is length into width. If we have 2-digited sides, 5.37 by 3.6. We have to continue doing this no matter how many digits we have. Principally, we agree to create tiny squares, and this is going to happen every time. I mean, we find out area of every tiny square and distribute it to the total number of squares, and hence we end up getting length into width. So for all rationals, these are rational numbers. All rational numbers, area of rectangle is length into width for all rational numbers. But real numbers are not rational numbers. Therefore, we will be in trouble. So we have to take side which is not rational and discuss what do we do. Suppose I have a side, I have a rectangle whose side is √5 and √2. Of course, we can have a segment of length √5. We can have a segment of length √2. Yes, now we have got Pythagoras theorem. So if I want to create a segment of length √5, I will draw right angle triangle with side 2 and 1. Right? Then this is going to be root 5. This segment is going to be root 5. If I want root 2, I will draw right angle triangle of 1 and 1. This side will be root 2. So we can draw root 2 segment root 2, segment having length root 2. But then it will be ambitious to say that area of this rectangle is root 10. Because if we start following the procedure, then root 5 and root 2 both are very difficult numbers. We will be in trouble. तर थोडा विचार करा आणि सांगा मला काय करूया. उत्तर हे येणार आहे कारण लेंथ इंटू विड्थ हे युनिव्हर्सल आहे. पण 2000 वर्षांपासून चालू आहे त्यामुळे ते बरोबर आहे. पण किती टायनी स्क्वेअर्स इथे लावूया छोटे छोटे सांगतायत. इथे सगळे मोजायचे प्रत्येकाचा एरिया आणि मग सगळं करून शेवटी रूट 2 आलं रूट 10 आलं पाहिजे उत्तर. इट इज डिफिकल्ट.
Dividing the rectangle into two triangles and using the
From rectangle we are going to go to area of triangle which is half base into height. So that is what I have assumed, therefore I am doing this discussion now. So using half base into height we cannot find out area of this rectangle because I am doing rectangle to find out half base into height.
okay.
Now, answer for this question is very difficult to get right away on the spot, fresh, unless somebody knows. It is very difficult to answer this question. Why is it going to be root 10? So, therefore, let us not waste time, spend time on that. Even if we understand the explanation, we are good. Or do you want me to wait for some time? If it comes to irrationals, this is irrational. Then things are totally different to deal with irrational numbers. Okay, the approach is, now if we try to write down this root 5 in the decimal form, then the digits are never going to stop. That is the problem. The moment I stop, it no more remains irrational number. It becomes rational. So for me to write root 5 in decimal expression, the condition is I should not stop. I should continuously keep writing the decimal points. So if I stop at say 100th decimal, then this method will work. I mean, conceptually it will work. We may not be able to divide the square in that many parts, but then we will be able to figure out, yes, after 100 digits you are stopping, so divide the square in so many parts and put every small part over there, and then yes. But then the problem with irrational number is the digits are dynamic and they are not supposed to stop. That is what that irrational number is. The moment they stop, it is rational number. So we have to deal with situations like this. However, what we do is root 5 can be caught between 2 and 3. Root 5 is greater than 2 because square of 2 is 4. Square of 3 is 9. So root of 5 is between root of 4 and root of 9. And this is, we are happy with 3 and 4, correct? Now, root 2 can be caught between 1 is greater, less than, root 2 is less than 2. Correct? This is possible. Now, suppose we are not happy with this. What do I mean by this? What do I mean by this is, I mean, if you draw 2 and 3, no? So the length is greater than 2 squares, but it is less than 3 squares. Do you understand this? This is 1, 1, and this total is 1. So the given rectangle, okay, let me draw it like this. And this is 1, so it is greater than 1. So let us say that this is a square and this is 2. So the white rectangle that we have is caught between a smaller size rectangle whose sides are 2:1 and a bigger size rectangle whose sides are 3:2. Okay, so I can conclude that the required area of rectangle whose sides are √5 and √2, the area is going to be between 2 to 6, 2 to 6, because for integers we have proved that the area is length into width. बघा समजतंय का? But then this is very bad approximation or very bad statement that area of given rectangle √5 2 is greater than 2 and less than 6. So it doesn't mean anything. So maybe what we should do is I take say 2.2 here. Square of 2.2 is 484. So 4.84 square of 2.2. 4.84 is less than √5 and then √5 is less than 2.3. Square of 2.3 is 5.29. Correct. So I can catch √5 between two rational numbers which are one-digited rational numbers. And here 1.4 is smaller than √2, is smaller than 1.5. 225 and 196. बघा समजतंय का? So now I have a better rectangle here. So let me draw 2.2 wala rectangle and 1.4 wala rectangle. So now the orange rectangle area is relatively closer to the required area, and then this also has come back. So this is where we are. So orange area is little smaller than the required area, and maybe green area. Sorry. Green area is little more than the required area. Yes, we are done. And then you continue doing this, and then in case of irrationals, if we have 100 digits over here, then for all practical purposes, we are done. We are sandwiching the required area between the areas which are measurable by our method. And the gaps are going to be substantially reducing in limiting case. If we continue this process, then the required area is going to be length into width. Okay, so this is the explanation where actually we require calculus. This limiting case consideration is the gift of Newton 300 years before. So before that, of course, limiting case was there, but it was not formally done. I mean, this is much older than 300 years, but formally now it is available. So if we keep doing this ... then area of rectangle is length into width with proof. No matter what length you have, no matter what width you have, you will get length into width as a rectangle. So this is very important breakthrough. And if we have it, then now triangle is easy. Yes. Question.
Basically, you're trying to root 5, you're trying to take it to root 5, you're trying to finalize as a rational number to the 100 or whatever.
No, we are not equating it. We are just nesting it.
Closing, but
Yes. No, approximate also. No. I'm not doing any approximation. I am nesting it, catching. Yes. Yeah, limit is calculus. Yes. Yes. And whenever we end up going to be in trouble due to irrational numbers, we are supposed to do this every time. This is the first time we are doing. Okay, so now we have rectangle, length into width without half base into height. So now suppose I have a triangle, or maybe before triangle, let us have parallelogram. I mean, we have to define parallelogram. We have to define what do we mean by parallel. वगैरे वगैरे सगळं ते येणार आहे. So rectangle we have done. Now we want to find out area of parallelogram whose sides are length is L and vertical height is H. So what should be the area of this parallelogram? It is easy because what we can do is draw perpendicular from this vertex over there. Hopefully it is falling inside. In the given figure, at least it is falling inside. Then we draw it here. Both sides not required. Using congruency, we can prove that this triangle is congruent with this. So the area which is added equal to area which is subtracted. So instead of finding out area of parallelogram, we can convert the parallelogram into rectangle using congruence. This is right angle triangle, which is going to be congruent with this right angle triangle. Therefore, their areas are equal. Congruent figures have equal area is a postulate. Nobody can question. So we are using congruent figures and their equal areas. So we did not have this area, but we had this area. Therefore, effectively, area of a parallelogram is length into height. Now there is one flaw in this proof, which is suppose I have a parallelogram looking like this. Then what did we do? We drop perpendicular from this vertex onto the base, and it is not falling where we want. Therefore, we are in trouble. But that is fine. I mean, you can use this. ठीक आहे, समजतंय? मी परवा जे तुम्हाला सांगत होतो, your idea is to drop perpendicular on the segment. Very good. But if it doesn't fall, then what? That is what is happening here. Idea is to drop perpendicular from this vertex over the base. Like this, it is falling, but not necessary every time it will fall. Okay, so area of a parallelogram again is equal to length into height. It is not this side W we are using, it is the height of parallelogram which we are using. And because it is rectangle. And hence now if I have a triangle, what do we do? If I have a triangle whose base is B and height is H. If a triangle has got base B and its corresponding height is H, then the area of triangle is how much? Okay, let us complete the parallelogram. A, B, C, D. If we complete the parallelogram, of course, we will require properties of parallel lines to show that ABC is congruent to CDA. Again, we don't have, but we have to assume. So ABCD is a parallelogram, and if you join any one of the diagonals of parallelogram, it gets divided into two congruent triangles. Or at least we have to use parallelogram properties. This side is equal to this side is equal to this. Therefore, by SAS, these two triangles are congruent, and therefore, area of parallelogram is B into H, and we are using triangle. Therefore, area of triangle is half B into H. And square is a rectangle, therefore side into side, length is side, height is side, therefore side square. So whatever we have used in Pythagoras proof, we have proved it. Okay, if I don't have parallelogram, because I have not done anything with parallelogram, let me check whether I can do away with rectangle. Suppose I have a triangle and I don't have parallelogram with me, but I know the height. Okay, I can complete a rectangle. ABC, DE. Okay, we can always complete rectangle. And this base was B, and this height is H, therefore this is also H, because we are completing rectangle, and area of rectangle is B into H. Good. Now, suppose B to F, this point is X, and this is B minus X, F to C. So area of this rectangle is X into H. And now we know that these two triangles are congruent. Therefore, X into H by 2. How much is this area? X into H by 2. And how much is this area? B minus X into H by 2 plus B minus X into H by 2 is required area of triangle, which after simplification we will get B into H by 2. So we are not touching parallelogram, we are doing it in rectangle. However, if what is the trouble in this now? The trouble in this is this triangle. So base is B and height is H. And I have obtuse angle triangle. So how do I find the area of that? And it has to be again half base into height. So our procedure was to complete rectangle. Correct? Let us assume, let us make this X. So area of this, how much? X into H by 2. And area of big rectangle, B plus X into H by 2. Correct? Area of big rectangle is B plus X into H by 2. And sorry, not big rectangle. Area of this is B plus X into H by 2. But we want orange area, therefore we have to subtract X into H by 2, which is equal to BH by 2. So whether the triangle is acute, whether the triangle is obtuse, and if it is right angle, then it is the easiest case. You just draw diagonal and you get right angle triangle. So all three cases we have proved area of triangle half base into height. So we can use it now in Pythagoras and we can do our job. एकता झाला. Okay, just like the identity a plus b bracket square is equal to a square plus b square plus 2ab. We can easily prove it, but I'm not getting into that right now. Why? What is the identity a square minus b square? Equal to. A square minus b square can be factorized into aha. Now, if I ask why, then it is a very difficult question. Why a square minus b square is a minus b into a plus b? So adding and subtracting what? AB. A square plus AB minus AB minus b square is equal to a common a plus b minus b common a plus b. Therefore, a minus b a plus, correct. But then this is very innovative. Something which is cancelled is very difficult to retrieve. And therefore, many difficult problems in geometry or algebra, you will find that something is disappearing. Then the problem suddenly becomes very, very difficult. We have to bring that disappearing quantity back into the game, and then it becomes simple. Now, this is simple because we know a plus b into a minus b is equal to a square plus ab minus ab plus minus b square. So from here to here, easy. From here to here, extremely difficult. If we have experience, then it is easy. Otherwise, it is very difficult. Okay. So that is what I will require to do next. Now, area of triangle is half base into height, but I have a triangle ABC whose sides are known, small a, small b, and small c. I do not know the height. All three sides I can measure, but I don't know how to go about measuring the height. Or this is sugarcane farm and आतमध्ये जाताच येत नाही. बाहेरून साइड्स मोजता येतात फक्त. And then I want to know what is the area of my farm. So need to work out. So suppose I draw perpendicular. We don't know how to do it. So I draw perpendicular. This is what is going to be height edge. And I don't know where this foot of perpendicular is going to go and lie. Suppose it is at x distance, then the remaining distance is a minus x, and this is 90 degrees. Correct? So let us create a symbol. Area of ABC. We will call it as delta. Easy to write. So delta is equal to, if that height was available, a into h upon 2. सगळ्यांनी नीट लक्ष देऊन मी काय करतोय ते बघितलं. इफ यू पे प्रॉपर अटेन्शन, देन ओनली यू विल रीच एंड. Otherwise, you will be lost in between. This is going to be equal to 2 delta is equal to AH, which is equal to 4 delta square, which is equal to A square H square, which is also equal to 16 delta square which is 4a square h square. This is my homework. Okay. Now let us go to the triangle, and we have Pythagoras with us. Therefore, our job is to find out h in terms of ABC. If we could express h in terms of ABC, we will be able to find out the area of this triangle. So let us start working. First, we have to get this h in figure in the calculations. So c square is equal to x square plus h square by Pythagoras to triangle ABD. Also, this implies h square is equal to c square minus x square. Also, b square is equal to h square plus a minus x bracket square, which is h square is equal to b square minus a minus x bracket square. Now we have the same quantity both the sides, therefore we can equate. This implies c square minus x square is equal to b square minus a square minus 2x plus x square, which is equal to c square minus x square is equal to b square minus a square plus 2x minus x square. You will observe that minus x square is present both sides. Therefore, I can write 2x is equal to c square plus a square minus b square. And therefore, x is equal to c square plus a square minus b square upon 2a. बरोबर आहे. Now I could express x in terms of small a, small b, small c, and I know h and x, they are connected here. So if I replace this x by this quantity, I will be able to express h square in terms of ABC. बघा समजतंय का? We have found out x in terms of ABC. We wanted h in terms of ABC, but they are connected to each other. Therefore, we say c square is equal to c square plus a square minus b square upon 2a bracket square plus h square. Therefore, h square is equal to h square is equal to c square minus c square plus a square minus b square a whole bracket. तर तो एच स्क्वेअर राहू दे, आपला इथे आपण एच स्क्वेअरच तयार करून ठेवलेला आहे, त्यामुळे तो एच स्क्वेअर तिथे चालेल आपल्याला. आता RHS ला अल्जेब्रिक स्किल्स वापरून थोडं सिम्प्लिफाय करूया. डिनॉमिनेटर इज 4a square, so I have 4a square c square minus inside bracket c square plus a square minus b square bracket square divided by whole divided by 4a square. बरोबर आहे. So whole divided by 4a square लिहायच्या ऐवजी I put that 4a square in the denominator to LHS. So 4a square h square is equal to 4a square h square is equal to that quantity, which I can replace by 16 delta square. So 16 delta square is equal to this. Now this is a perfect square, this is also perfect square. So using our identity, we can say 2ac plus c square plus a square minus b square into 2ac minus c square minus a square plus b square. बरोबर आहे. which is equal to now a square plus 2ac plus c square, which is a plus c bracket square minus b square whole bracket complete. Here we do c square ac. If you look at this, it is going to be b square minus a plus a minus c bracket. बघा जरा बरोबर आहे का? बी स्क्वेअर मायनस ए मायनस सी ब्रॅकेट स्क्वेअर बरोबर आहे, विच इज इक्वल टू ए प्लस सी प्लस बी ए प्लस सी मायनस बी हा झाला पहिला ब्रॅकेट आणि दुसरा ब्रॅकेट बी प्लस ए मायनस सी इंटू बी मायनस ए प्लस सी दूसरा ब्रॅकेट. Good. Now let us go back to triangle ABC. Perimeter of triangle ABC is equal to small a plus small b plus small c. Hence, semi-perimeter is equal to a plus b plus c upon half of perimeter is semi-perimeter, which is by 2. Okay, so which is also denoted by small s, semi-perimeter. Now I wish to know how much is a plus b minus c upon 2 equal to. I want to find out how much this is in terms of semi-perimeter. So what I do is a plus b plus c, which I am good at this, minus 2c upon 2. I write this quantity as this, and then I can break it into parts. A plus b plus c by 2 minus 2c by 2, which is equal to s minus c. So if I take one of the three negative, then it is eventually semi-perimeter minus c, whatever we take here. Correct? Now I have 16 delta square, 4 brackets here. Therefore, I write delta square is equal to, and I have 4 2's here. 2 into 2 into 2 into 2. So distribute each 2 to 4 brackets. We get a plus b plus c by 2, first bracket. A plus c minus b by 2, second bracket. A plus b minus c by 2, third bracket. And b plus c minus a by 2, fourth bracket. Which we can say s into s minus a into s minus b into s minus c is your delta square. This is Heron's formula. For finding out area of triangle using sides. Again, not very difficult because we are just using Pythagoras, and for proving Pythagoras, we are using congruence. Heron's formula for finding out area of any triangle using sides. This is, so delta is root of all this. Yes. Any doubt, difficulty in any step, you can ask me.
सर ती स्टार वाली स्टेप कन्सिडर केली का?
हा इथे तुम्हाला हा एस मायनस बी लिहिला ना मी. इथून इथे दिस इज एस मायनस बी, दिस इज एस मायनस सी अँड दिस इज एस मायनस ए.
सेमी पेरिमीटरच्या खाली घेतलंय ना, स्टार इज इक्वल टू ए प्लस बी मायनस सी अपॉन 2. हे कन्सिडर केलं का आपण?
नाही, मला माहिती आहे की याची किंमत मला काढायला लागणार आहे, कारण ती इकडे लागणार आहे. ए प्लस बी मायनस सी बाय 2 हा बघा इथे.
ओके ओके, सो इट इज कन्सिडर अँड देन इट इज डिराइव्ड एस मायनस सी.
Ah, so we have to write a plus b minus c by 2 as s minus c, and then suddenly if I write that, then there will be questions. Therefore, I have explained it here. Now this proof, Heron's formula is given to student directly. It is never taught with proof in any of the board syllabus.
सर
Yes.
सर मला ते सी स्क्वेअर इज इक्वल टू ब्रॅकेट मध्ये जे लिहिलंय ना ते नाही कळलं.
हे का?
हा
हा, हे कळलं?
हो
हे
हो ते पण कळलं.
x ची व्हॅल्यू काढली ना आपण ही. आणि हे
हा.
कळलं? हे कळलं का?
हो ते कळलं.
हा, मग इथे x जे आहे तिथे हा लिहिला.
ओ ओके ओके ठीक आहे.
हा. We have proved now, which should have been proved earlier, before Pythagoras,
It is based on area of rectangle.
which we have defined just now. Before proving half base into height, we have proved rectangle, length into width,
First rectangle, then
first rectangle, then triangle. First square, then rectangle, then triangle, then parallelogram. Okay, so it is time to give you some numericals. Find area of triangle whose sides are 13, 14, 15.
सर
Yes.
तर 84 स्क्वेअर युनिट.
काय माहिती?
सर
हा बघतो, एक मिनिट, जरा 4 जणांचे होऊ दे, मग बघतो.
तर बोर्ड थोडस स्क्रोल डाऊन कराल का? मी प्रूफ थोडं बघतीये. माझं झालंय ते, त्यामुळे. थँक्यू सर.
84 is the right answer, sir.
I am not happy with the answer. I am not happy with spelling out the answer. Hmm. $84. हाँ. S is less than. न्यूमेरिकली ना, नाही. Semi perimeter is less than area. Area of sides म्हणजे काय?
S is less than.
नाही नाही ना, होणारच नाही ना, because A is part of S and it is added with B and C. So S is going to be greater than A by 2. S is going to be greater than A by 2. S is going to be greater than B by 2 and S is going to be greater than C by 2. That triangle is not possible. Triangle with 4 to 1 is not possible. You cannot draw a triangle with 4 to 1. Let us try. 4 काढली. 4 काढली. मग 2 चा रेडियस घेतला म्हणजे हाफ एक सर्कल मारला आणि मग 1 चा घेतला दुसरा भाग. No, in this case it is not because we are dealing with actual dimensions. We are dealing with figures, so it will never go negative inside radical. Okay, so if I want to make this question little difficult, I will ask find the height of triangle ABC with base BC given AB is equal to 13, BC is equal to 14, CA is equal to 15. If I ask this in the first place without asking this, then this is a difficult question. Because I'm not telling you to find out area using Heron's formula. It is to be assumed that yes, we are supposed to find area first, and then using area we are supposed to find height. So this is one jump problem. You use Heron's and you get it. So these are school problems. These are difficult ones. Heron's is not there in the question statement. We have to find out Heron's because all 3 sides are given to us. This is two jump problem. Okay. अर्धा percent. Okay, what is going to be the height? 12. चौदा चौऱ्याऐंशी. Height 12. Now, normally when I do this proof with students and I want them to learn this proof in one go, not at home, in the class itself, the trick which I use is I ask them to close their notebooks and keep the pens down. Just look at what I am doing. Observe करा काय करतोय, कोणत्या कोणत्या स्टेप्स घेतोय. त्याच्यानंतर त्यांना 5 मिनिटं देतो अजून. तुम्ही बोर्डकडे बघत राहा, मेमोराइज करायचा प्रयत्न करा. Which are the steps to be followed to prove the area of triangle using Heron's formula. Then I erase the proof. Then I ask them to write down the proof in their note. In one go, 15 minutes, students learn this proof without referring to my notes on their own. आता जर मी हे सोडून दिलं, जेव्हा कधी अभ्यास करतील मुलं तेव्हा ते बघणार परत. कदाचित प्रूफ कोणी विचारत नाही हे त्यांना जर माहिती असेल आधीपासून, तर ते हे प्रूफ कधी करणारच नाही. परीक्षेत नाही म्हटल्यावर करणार. त्यामुळे म्हणजे असे आणि दे गेट एक्साइटेड की अरे लिहायचं काही नाहीये, म्हणजे पहिला आराम करायचा आहे, बसा बघा काय चाललंय, जस्ट वॉच and they will catch me if I am doing something wrong with full attention. Then I don't disclose them initially की तुम्हाला नंतर मेमोराइज करून लिहायचंय म्हणून. ओके, तुम्ही मजा बघा फक्त काय काय चाललंय ते. इफ यू डू दिस कॅल्क्युलेशन्स यू एंड अप गेटिंग इट. अँड आता तुम्हाला एक्साइटमेंट जरा कमी आहे, पण द मोमेंट वी राईट दिस अगेन they start shouting because they know this formula and it is the first time that it has come on board with a lot of calculations, therefore tremendous excitement that Heron's formula is proved. And then when I ask them to write it in their notebook, majority of the students will complete it without any problem. I'm not going to do that now, but that is what is the way we deal with students. They like challenges, and that is how you create interest in students. Okay, आता काय शिकू? So let us do complete Pythagoras theorem. Okay, त्याच्या आधी one more application. Suppose I have a triangle, right angle triangle ABC, whose angles are special 30, 60. This is a special right angle triangle 36. Why? Because angles are in arithmetic progression 30, 60, 90. And these are friendly angles 30, 60. So prove that AC is equal to twice BC. If the triangle is 30, 60, 90, then this has to be there. हा करू का? टू टाइम्स BC करायचं. So let us extend this BC to the other side and stop when BC is equal to BD. This is 90, therefore this side also it is 90. And this is common side, AD. Therefore triangle ABD is congruent with triangle ABC. एवढा वाईट का दिसतोय? Therefore corresponding angles must be equal. Remaining sides must be equal. Corresponding angle. This is 60, this is 30, and this is equal to. But then ADC is equilateral. Therefore AC is equal to AD is equal to CD. But CD was 2 times BC. Thirty, 60, 90 if reflected becomes equilateral triangle, and therefore side opposite to 30 degree in triangle 30, 60, 90, side opposite to 30 degree is half of hypotenuse. So in 30, 60 degree given same configuration, angle A equal to 30, angle C equal to 60, angle B equal to 90. If AC is equal to 10, if AC is equal to 10, find AB and BC. Simple. Using Pythagoras. Now, if the triangle is special, whose angles are special angles, then only one side is enough to find out remaining two sides. Because 30, 60, 90, we know the information that side opposite to 30 degree is half of hypotenuse. So now I am giving hypotenuse AC as 10. Therefore, BC is equal to, this implies BC is equal to 5. Therefore, AC is equal to AC square is equal to, sorry, BC CA, CB, BC square is equal to AC square minus, अरे काय चाललंय, AB पाहिजे ना इथे. AC दिलाय, BC दिलाय, त्यामुळे AB square is equal to AC square minus BC square, which is 10 square minus 5 square, which is 75. So AB is equal to 5√3. So in 30, 60, 90, if we get one side, we can find out the remaining two sides orally. ठीक है. So suppose now BC is given 7 and how much CA 14. How much AB 7 root 3. ठीक है. Suppose AB is given 15 root 3 and how much is BC 15. How much is CA 30. Okay. Suppose AB is given 10. Find BC and CA. Suppose AB is 10, then find BC and CA.
Ten by root three and into 2. 20 by root 3.
Hmm.
Ten by
Okay.
root 3 and 20 by root 3.
Correct. Chalo, let us finish one more special triangle ABC with AB equal to BC, which means these angles are 45, 40. Sides opposite, isosceles triangle property we have proved. This is 90. Okay. So if AC is 10, find BC and AB. Forty-five, 90. If the triangle is 45, 90, and any one of the sides is given, then we can find the remaining two sides.
Five by root 2.
Are you by root 2? Suppose this side is x, then this is also going to be x. So 2x square is equal to 100. Therefore, x square is equal to 50, which is equal to 25 into 2. Therefore, x is equal to 5 root 2. So if any one of the sides is given, remaining two can be found out in 45, 90 and 30, 69. Okay. Any questions? Whatever we have learned today.
सर एग्जाम में प्रूफ्स आएंगे क्या थ्योरम?
अभी डिसाइड नहीं किया है.
ओके.
Okay, I think this is little heavy today, so we will stop 12 minutes before. Any questions we can discuss, otherwise lecture is over. Ha, बोलो.
सर मला नाही समजलं ते 10च.
टेन्शन नाही समज.
आपण नाही इकडे सर.
इकडे का? हा, ओके. 10 अपॉन रूट 3 कसं आलं? तर जर इथे रूट 3 असेल तर हा इथे असतो आणि याच्या डबल इथे असतो. आता रूट 3 नाहीये, मग 10 ला आपण असं पण लिहू शकतो 10 रूट 3 अपॉन रूट 3. root 3 cancel, therefore 10. So 10 can be written like this. And we are happy to have this numerator root 3 here. Doesn't matter whatever other thing we have, this thing we goes here, 10 upon root 3 and double of that goes here. This is one way of explaining. Second way of explaining is you want to find out BC. This is 10, this is x, and this is 2x. Correct? So x square plus 100 is equal to 4x square. Therefore, 3x square is equal to 3x square is equal to 100. Therefore, x square is equal to 100 by 3. X is equal to 10 upon.
√3.
Ah.
Thank you, sir.
Thank you. Chalo, see you on Thursday. Bye. Thank you.
Thank you,
Yes,
sir.
sir.